Okay, we've talked about similar polygons. All right, we didn't just deal with triangles. We've dealt with squares and all kinds of different things like that. But today we're gonna specifically talk about similar I said polygons, but I meant triangles. So we're gonna be more specific, and we're gonna talk about similar triangles. So let me just grab a triangle right here. This is just any old triangle, nothing special. We're on 7.3. You can find it. It's right there. Watch this. I took this triangle, I copied and pasted, and all I did was just make it a little bit bigger. I didn't change the shape of it at all. So these are similar triangles. Up to this point, what did we have to know about similar triangles? We had to know actually 6 different things. We had to know that all 3 corresponding angles were equal to each other, right? Was that enough? No, we also had to say what was true about the sides. They were what? They were in proportion. A, B, C, D, E, F. So we had to know that all the angles were equal to each other, and we also had to know the sides were in proportion. So I could say what? A over D needs to equal what? B over E equals C over F. So I had to show all those things. That's 6 things, isn't it? 3 angles and 3 different ratios. So I had to show 6 different things in order to say that these were similar triangles. Well, they made it a little easier for us, and we don't have to necessarily show all 6 of those things. Do you remember back when we did congruent triangles? We said if you could just show that 3 sides of one triangle equals 3 sides of another triangle, then those triangles were congruent. We didn't even have to say anything about the angles at all, did we? All right, so it was kind of like a shortcut. Then we had another way. We had what? I don't have to show all 3 sides. Right, I could show 2 sides and an included angle, and then those triangles were congruent. Then another way, I could show 2 angles and a what? Included side, and those triangles were congruent, right? It was shortcut. You didn't have to show all 3 angles equal and all 3 sides equal. Same thing here. There's actually a shortcut for similar triangles. And I'm not going to get into a ton of details here just for the sake of time. So let me just put them on here. The first one is the best one, I think. We call it angle-angle similarity. I taught out of a book a couple years back, well, a lot of years back now. They would call it the angle-angle-angle. But think about it. You don't really need angle-angle-angle. I'll show you if I can. There we go. There. Copy, paste.
Is it like 3D or something?
3D? No? Okay, let's take a look at this. If I had this angle and this angle equal to each other, and I had this one and this one, do I really need to show that all 3 angles are equal? Because watch, if these 2 angles are equal to these 2 angles, what must be true about the third angles? The third angles must be equal anyway, okay? So if I can show that all 3 angles are equal to each other, which basically all I really need to do is show that the 2 are, right? Because if the 2 are equal, then the third automatically are going to be equal from a theorem that we had earlier. If I know that that stuff is true right there, let's do this. Let's just group this, because what I'm going to do is something I did before. Then I could take this and watch. I could put it on top of here. See, that angle's equal. I could put it on top of here. That angle right there is equal. And I could put it over here. This angle down here is equal. So all 3 angles are equal. The only way that all 3 angles are going to equal these 3 angles right here is if I just change the size of it and I didn't change the shape. So what does that mean? That means they're going to be similar triangles. They have the same shape. As long as they have the same shape, they're similar triangles. So really all I have to do is show that 2 angles of one triangle equal 2 angles of another triangle. If that situation is true, if these 2 angles equals these 2 angles, guess what I could say about these 2 triangles? They are what? Talk to me. Similar. That's right. They're similar to each other. That's all I have to show. I don't even have to show that the sides are proportional to each other. Okay? All I have to show is that this angle and this angle equals this one and this one. And then they're similar. Now, since we know they're similar, what must be true then about the sides? The sides must be what? Give me the word that we've been using. No.
Proportional.
Proportional, that's right. Okay, proportional. Okay, CPCTC is only with congruent triangles. We're not doing congruent proofs. Okay, CPCTC is for congruency. We're not doing congruency. This is similarity. So watch. This side to this side, if I compared this one to this one, it would equal this bottom one to this bottom one, this right one to this right one, just like we showed before. So that's all I have to show. There's another, let me get rid of this. There's another way to do this. I'll use the same triangle. And again, let's just make this one a little bit bigger. Okay, so these are... Now, right now, do I know they're similar triangles right now with the information that's given? No, there's really no information given. The only thing that's given is I got two triangles right here. But what if I knew this? What if I knew that, let me see what it says. Corresponding lengths of the two triangles are proportional, then the triangles, okay. Yep. What if I knew, we'll do this again. We'll use the same letters just to make it easy for us. Okay. I don't know anything about the angles. I don't know that this angle is equal to this one. I don't know. All right. I haven't been told any of that stuff. But here's what I do know. They told me that A over D equals B over E, which equals what? C over F. All right. That's what they told me. Let's get rid of this. They didn't say anything about the angles at all. Now, they didn't tell me angle A is equal to they didn't tell me that side A is equal to side D, did they? They didn't tell me that side B is equal to side E. They told me that the ratio of the sides are equal to each other. That means they're in proportion. So if these sides are all in proportion, guess what I can say about these two triangles then? They are what? Similar, that's right. So if with this information right here, with this information given to me, I can now say that these two triangles are similar. Now, if they're similar to each other, what then can I say about the angles? The angles are all equal. The corresponding angles are all equal. So now that I know that they're similar, now I could say that this top angle equals this top angle. This bottom left one equals this bottom left. The bottom right equals the bottom right. Does that make any sense? So now I know that they are similar to each other. We call that the side-side similarity. It's not just plain old side-side. It's side-side similarity because the regular side-side told you what? That side A was what to side D? Congruent, equal to each other. That's right. Okay, that was regular old side-side. That was with congruency. Now we're talking about similarity, so we call this the side-side similarity postulate. Okay? I didn't know anything about the angles, did I? But I did know that all three corresponding sides were in proportion. If I knew that, then that's enough to say that those triangles are similar. Let's do another one. And this is pretty much it. Let's change colors here. What do we use? Tell you what. I was watching Khan last night. He was using like dark colors, but I don't have too many dark colors on here. Which one do you want to use? Blue, global green. We'll go global green on us. Okay, let's see what this looks like. All right, let's do. Oh, that messed my color up because when I pasted that, it changed my color thing back to white. But that's okay. Let's do this again. We'll use the same triangles. It's just, I mean, we could use different triangles, obviously, but we're not going to. Watch what's given to us here. Let's go back to that green. Sea green? Is that you? Okay. I don't even know if I'll be able to see it. So watch what's given here. And it would be easier, I think. Can you even read that?
Yeah, no.
That's right. Open your eyes. Alright, we'll go jade. Alright, here we go. Let's see what's given to us. We're given that angle S equals angle Y. I'll make the point size a little bit bigger so it'll be a little easier to see. Now, right there, just given that these two angles are equal to each other, does that mean those triangles are similar to each other? No. Now, if I knew that maybe like T and Z were equal to each other, yeah, they would be similar because of angle-angle similarity. But that's all I know. Now, watch what else I know. This is what else. This is the other thing that they tell me. They tell me that SR to YX equals ST to YZ. Now, Now again, they don't say that this side is equal to this side and this side is equal to this side. They say the ratio of the sides. The ratio of this one to this one is equal to the ratio of this one to this one. It means those two sides are in proportion. Now notice, I didn't just get any two sides. This angle right here is between my two sides. You see it? So it's the included angle. So if I have two sides that are in proportion and the included angle is equal to each other, do you hear what I just said? If I have two sides of a triangle that's in proportion, right? So I've got, now look, I'm going to mark it like this, but it doesn't mean they're equal, right? It just means they're the ones that correspond to each other. And I'll mark it like this. See, I'll make this extra big. Everybody with me on that? So look, if I have two sides that are in proportion and the included angle, give me a second, and the included angle is equal to each other, guess what's true about these triangles? They are what? Similar. What do you think we call this? Side angle side what? Similarity postulate. Okay, that should be enough, I believe. They have an example in here. If you want to go look at the example in the book on your own, then feel free to do that. Let me give you some problems to do. Guys, just pay attention, please. I know the bell rang, but I'm giving you the problems. 479, 480, and 9 to 24.
What?
9 to 24.
What section is this?
7-3. Section 7-3. All right, have fun with that.
If you were scheduled for an